Hello friends, welcome to Jatin Academy. So today in this class we will learn about chapter 3 machine part A, that is introduction of machine, class 10th ICSE. So here we will see about the introduction of machine. Next we will see the function and uses of a simple machine. Next we will see definition of machine. Now after that we will see technical terms related to machine. In technical terms we will see about load and effort. Next we will see mechanical advantage and velocity ratio. Then work input and work output. After that we will see the efficiency, and at the last we will see the principle of machine. So let's get started. Now let's start with the chapter with the introduction of machine. So before understanding the definition of machine, let's understand the function of machine in our daily life. So basically the main function of the machine is to make our work simple and easier. So here we have a different kind of machine. Without the machine we can't think of our life. For example, if you want to cut a cloth with the hand, can you able to cut the cloth? No. So here you need a scissor, or you want to put a nail in the wall. So if you want to insert a nail in the wall, you need a hammer. With the hand it's very difficult to insert a nail in the wall. Or if you want to move from one point to another point, or from cover a distance, then you need a bicycle. It means that at every aspects of our life we need a machine. Now let's see the different functions of a machine. So for example, you are going on a trip, and in between a trip your tire car gets punctured. Now what you will do? You will replace it with stepney. So before replacing, here you need some device which lift up your car, and that device is called screw jack. Maybe you know this name. The screw jack is required to lift up the car. Otherwise, with the help of hand you can't lift up the car, because car weight is too much, nearly 500 kg. If I'm talking about, this is very less. More than that the car is having weight. So here you need a device which convert your less force, means here you are applying only 3-4 kg. Okay, so 3-4 kg force is converted into 500 kg to lift up the car. So this is the first example of, or first function of a simple machine. Here what they are doing, this machine what is doing, it is converting your less force into more force. Okay, converting your less force into more force. So this conversion of less force into more force, this is called force multiplier. So here in lifting a heavy load by applying a less effort, what is effort I will explain later, but here we are lifting a car with very less force, we are applying very less force, so that function is called force multiplier. Next we have a bicycle. So here carefully see, actually the rear wheel is rotating. Here rear wheel is rotating, but we are applying force on the pedal. We are getting force here and we are applying force here. So we are changing the point of application of force. Carefully understand again this part. Here we are on the pedals, we are applying the force, and on the rear wheel we are getting the force, means actually the rear wheels are rotating. So in this machine, in this bicycle, we have converted the point of application of force. Actually we are getting force here, but we are, with the help of some mechanism, we are changing this point to this point. We are applying force here and we are getting force here. So next function we are getting here in changing the point of application of effort to a convenient point. If our pedals are directly attached to the rear wheel, then it's very difficult for a person to ride a bicycle. So inconvenience for the person, for the convenience of the person, we are applying, or we are using a chain mechanism in which the pedals are put some forward, inconvenience of the human being. So here next function of machine we have in changing the point of application of effort. Effort means what force we are applying on the machine. So okay, so point of application of effort to a convenient point. Next function we have, for example, if you want to take the water from a well, okay, so if we don't use this pulley system, then what you will do, you have to take the rope like this, means you have to pull the rope and you have to apply the force in the upward direction. Applying the force in the upward direction is very difficult for a person. This is not a convenient direction for a human being. So convenient direction is pulling downward, okay, pulling downward or pulling toward itself. This is a convenient direction. So here when we are lifting the bucket from the well, a pulley system we have used, so we are applying the force in the downward direction, which is a convenient direction, and we are able to lift the bucket which is coming in the upward direction. So if you think, for example, pulley system is not there, then in order to pull up the bucket from the well, you have to apply the force in the upward direction, then only bucket will come in the upward direction. But applying the force in the upward direction is inconvenient to a human being. So that's why we are using a pulley system in which we are applying the force in the downward direction and we are getting the force in the upward direction. So that's why bucket is coming out easily from the well. See the function here. In changing the direction of effort to a convenient direction, means here direction of force is changing. This machine, what it is doing, it is changing the direction of the force. In the previous example, in case of bicycle, this mechanism is changing the point of application of force, means direction is same in this direction but point of application of force is changed. But in case of pulley, we are not changing the point of application of force, we are changing the direction of force. We are applying the force in the downward direction and we are getting the force in the upward direction. Next function we have related to a scissor. So when we use a pair of scissors used to cut a cloth, here if you will see carefully, when you move this handles to, for example, 2 centimeter, these blades move, for example, 4 centimeter. What does it mean? It means that the handle move little and the blade moves faster. Okay, so faster means here the speed is more and here the speed is less. So actually this machine is increasing the speed. With the help of very less displacement, we are able to cut a very large piece of cloth or large piece of paper. So here if you will see what is the function of this machine for obtaining a gain in speed. In the first example, we are able to lift up the car. There it is a force multiplier. Here we are not getting force multiplier. Here we are getting some increased speed. So when we are getting some increased speed, that machine is act like a speed gainer. So for obtaining a gain in speed, that is greater moment of load by smaller moment of effort. What does it mean, greater moment of load and lesser moment of effort? That we will discuss later, that what is load and what is effort. But for the time being, which force we are applying on the machine, that is a effort, okay, and the force which we are obtained from the machine, that is a load. But detailed discussion we will do later. Now after summarize this all functions, we are getting one definition of machine. So the definition of machine is based on their function. So a machine is a device which can either overcome a large resistive force. Overcome large resistive force means it acts as a force multiplier at some convenient point by applying small force. Convenient point means what? Here we are talking about change to a point to a convenient point. Okay, at a convenient point in a desired direction. So by applying a force at a convenient point, and we are getting also, we are using this machine also in the desired direction, means a change in direction here we are talking about, and by which we can obtain a gain in speed. So with the help of machine also we can gain in speed. Now carefully listen, all these functions cannot be obtained in a one machine. Carefully listen. So here for example, if we are overcoming large resistive force and if you are gaining a speed from a machine, these two things are not possible. So machine can do these types of work, but simultaneously it is not possible. So a machine is a device by which we can either overcome a large resistive force at some point by applying a small force. This small force or force applied by the human on the machine is called effort. At a convenient point where it is convenient for a human being, there only the human being will apply the force, and we are getting the result, or we are applying the force in a desired direction where it is convenient for us, and by which we can obtain a gain in speed, and sometimes we are also getting gain in speed. So basically this is a complete definition of a machine which we are taken from the functions of a machine. Now we have to see some technical terms related to a machine. So here, first of all, before going to the technical terms, let's understand this example. In this example, for example, this is a machine. This pulley is a machine. Okay. Here this person is applying a force on the machine, only then the machine will work. And here the pulley is actually raising a load, actually raising a some block. So this is basically a force applied by the machine on the block. So one by one we will see the terms. First term we have, that is a load. So what is load? Carefully see. The resistive or opposing force to be overcome by a machine is called load. For example, this block is a resistive or opposing force for this pulley. So this resistive or opposing force why? Because this block having weight, this block's weight is in the downward direction, and this pulley wants to move this block in the upward direction. Okay, so some kind of resistance is there. This block wants to move in the downward direction, but this pulley or this man wants that the block should move in the upward direction. So for this machine, this block is applying the resistive or opposing force. Now this is clear now, because here it is wants to move in the downward direction, and we want that the block should move in the upward direction. So both are in the opposite direction. So this is a resistive or opposing force which is to be overcome by this machine. So this is called a load, or simply you can understand the force applied by the machine on the block. This is called a load. Okay, next we have effort. So what is effort? Like this machine will not work by itself, we also have to apply some force on the machine so that it will perform some work. So the force applied on machine to overcome the load, this is called effort. So whatever this person applies force on the machine, why this person is applying force on the machine? So that this machine able to lift up this load. So the force applied on the machine to overcome the load, this force on the machine is called effort. Clear? So here if you will carefully see, load is a force. If load is a force, so SI unit of load is Newton. Effort is also a force. So if effort is also a force, so SI unit of effort is also Newton. Clear? Next term we have, that is a mechanical advantage. Mechanical advantage means what advantage we are getting from this machine. So that mechanical advantage formula we have, load upon effort. Clear? Mechanical advantage formula we have, load upon effort means how much this machine is able to lift a load and how much we have to apply the force on the machine so that this machine able to lift up a load. So the ratio of load to effort is called mechanical advantage. Now this value of mechanical advantage is divided into three parts, means three possibilities are there. First possibility we have mechanical advantage greater than 1, or mechanical advantage equals to 1, or mechanical advantage less than 1. When mechanical advantage value greater than 1, what does it means? It means that, carefully see, mechanical advantage greater than 1 means load over effort is greater than 1. So now multiply here, load is greater than effort. What does it means? It means that we are able to lift a high load, high value of load with less value of effort. Let's take example. For example, this block is of 50 kg and on the pulley we are applying only 10 kg. Now this 50 kg is what? Effort or load? So this 50 kg, actually this is not a force, this is mass. You can also convert it into force by adding kgf. Okay. So load we are having 50 kgf and effort we are applying on the machine is 10 kgf. So what is the value of mechanical advantage? Mechanical advantage we have 5 by 10, 50 by 10, that is 5. So here mechanical advantage we have 5 which is greater than 1. 5 value is greater than 1. So here carefully see, load we are getting more, means we are able to lift up the more load by applying a less effort. So this is an example of force multiplier. What does it means? It means that when mechanical advantage is greater than 1, it means that load we are able to lift higher or higher value than effort applying. So this machine whose mechanical advantage is greater than 1, that is called a force multiplier. Clear? Now see the next part, when mechanical advantage is equals to 1. So when mechanical advantage is equals to 1, the load upon effort is also equals to 1. It means that load is equals to effort. So the examples which you are watching here, that is a case of mechanical advantage equals to 1. Why? Because for example, if this block is 50 kgf, then you have to apply 50 kgf in order to lift the load. If block is 50 kgf and you also have to apply the 50 kgf, then what is the need of the machine? So the need of machine is that you are able to change the direction of effort. Carefully listen. Here load you wants to move in the upward direction, but you are applying the effort in the downward direction, which is convenient for you. So the machine whose mechanical advantage is equals to 1 means load is equals to effort. That machine, in that machine, it works like a change in direction. Clear this part? So here we are getting change in direction. Next we have when mechanical advantage less than 1. Mechanical advantage less than 1 means here same thing. Mechanical advantage is load upon effort. Mechanical advantage less than 1 means load upon effort less than 1 means effort is more than load. It means that it is a kind of machine where you are applying more force and you are getting less force. When you are applying more force and you are able to lift a block of less force, then what is the use of that machine? That machine is having different function which work as a speed gainer. Here you not worry about the force, there you worry about the speed. You want to complete your task quickly by providing the more force. So here when mechanical advantage less than 1 means load effort is more, you are applying more effort and you are able to lift up a less load, but that machine is having different function, that is it act as a speed gainer. It quickly moves the load with the higher speed with the less speed of your hand. Clear? Now if you talk about the SI unit of mechanical advantage, so mechanical advantage is load over effort. SI unit of load we have already discussed, that is Newton, and SI unit of effort is, it is also force, so this is Newton. So Newton cancel out, so this is basically a pure ratio. So mechanical advantage is having no units. Clear? Next we have next technical term, that is velocity ratio. So what is the meaning of velocity ratio? Carefully see. When you are applying the force on the machine, okay, So this is actually a effort point. Effort point means where you are applying the force on the machine or human being applying the force on the machine, that is called effort point. And where the machine is applying force on the load, that is called a load point. Okay, so when these points are moving, it is also taking some displacement, means some displacement is taking, and it is also having some velocity. So first of all, take the example of velocity. Here at the effort point we have some velocity, and at the load point we have some velocity. So the velocity at the effort point, that is called velocity of effort, and the velocity which we are getting on the load point, that is called velocity of load. So what is the velocity ratio? Velocity ratio is a ratio of velocity of effort to a velocity of load. Now what is velocity of effort, what is velocity of load? Now this point is clear. The velocity at the effort point is called velocity of effort, and velocity obtained on the load point, that is called velocity of a load. Now let's see one more formula of velocity ratio. Here we know that velocity is equals to displacement upon time. So velocity of effort is displacement of effort over time, and velocity of load is displacement of load over time. Time is same because the time in which effort is moving, in same time also load is moving. So here velocity ratio we got it as velocity of effort means displacement of effort over time over velocity of load means displacement of load over time. Time and time cancel out, so velocity ratio we got it as displacement of effort over displacement of load. So this is the one more formula and most important formula of velocity ratio, that is displacement of effort over displacement of load. If I am talking about the three cases, so again velocity ratio can be having three cases. First we have velocity ratio value greater than 1, second we have velocity ratio value equals to 1, and third we have velocity ratio less than 1. Similar to the mechanical advantage, we are getting the same thing. Here we are getting effort, so here it is a load. So here velocity ratio greater than 1 means what? Velocity ratio greater than 1 means velocity of effort over velocity of load is greater than 1. So velocity of effort is more than velocity of load. Carefully see, here we are giving more velocity and here we are getting less velocity. For example, here we are moving this rope, for example, with the 2 meter per second, and this block is only moving with the speed 1 meter per second. It means that we are giving more velocity and we are getting less velocity. So speed gainer is not possible. So this is an example of force multiplier. So in the force multiplier, we are giving more velocity and we are getting less velocity, but we are getting more force by applying the less effort. So this machine is act as a force multiplier. Clear? Now when velocity ratio equals to 1, velocity ratio equals to 1 means velocity of effort is equals to velocity of load. So when velocity of effort is equals to velocity of load, for example here also 2, here also 2, then what is the function of machine? That machine is act like a change in direction. Here you will also see the pulley cases. In the case of pulley, velocity ratio is equals to 1, mechanical advantage is equals to 1 for an ideal pulley. Why? Because it is only changing the direction, it is not increasing the speed, neither it is giving a force multiplier. So this machine is act as a change in direction. Last we are having velocity ratio less than 1. Velocity ratio less than 1 means velocity of load is more and velocity of effort is less. For example, velocity of load we have 5 meter per second and velocity at the effort point we have 2 meter per second. So here load is moving quickly, but we are applying the effort with the less speed. So here machine is quickly move a load. So this machine is act as a speed gainer. So similar to the mechanical advantage, we are getting the same thing. Mechanical advantage greater than 1 or velocity ratio greater than 1, force multiplier. Mechanical advantage equals to 1 or velocity ratio equals to 1, change in direction. Mechanical advantage less than 1 or velocity ratio less than 1, that machine is act as a speed gainer. So now if I'm talking about the SI unit, so velocity ratio is basically what? Velocity of effort over velocity of load. Velocity of effort we have meter per second. Velocity of load we have meter per second. Both are same ratio. So velocity ratio is a pure unit. It is having no pure ratio. It is having no unit. Clear? Next we have one important note in which it is written that a machine cannot be used as a force multiplier as a speed gainer simultaneously. What does it mean? Carefully see. When a machine is a force multiplier, mechanical advantage and velocity ratio both are greater than 1. And when the machine is speed gainer, then mechanical advantage and velocity ratio less than 1. It means a machine cannot have mechanical advantage or velocity ratio sometime 1 greater than 1 or sometime less than 1. So a machine cannot act as a force multiplier and speed gainer simultaneously. Simultaneously means coincidentally it can't work side by side, it work means a machine can be a force multiplier or it can be a speed gainer, but simultaneously both speed gainer and force multiplier is not possible. Next technical term we have work input. So what is the meaning of work input? Before understanding this term, let's understand the meaning of work. So what is work? Work is force into displacement. Means when we are applying a force on a body and body displaces in the direction of force, that is called a work. So here carefully see, this is called a effort point and this is called a load point. So the force applied by this man on the machine, that is called effort. This is a force and this effort point is also moving in the direction of force, means force is applying in this direction and effort is moving also in this direction. So the displacement covered by in the direction of force by the effort is called displacement of effort. Now similar to the case of load. So this machine is applying force on the load and force applying on this block is called load, and the load is also moving in the direction of force. So when the load is also moving in the direction of force, that is called displacement of load. So what is work input? Input means something is input to a machine, and who is giving work to a machine? A man is giving work to a machine. So in case of man, in case of work input, work done is equals to force. So this man applying the force on the machine, that is called effort, and the displacement occur on the effort point is called displacement of effort. So this is basically a work input. So what is the definition of work input? Work input means the work done on the machine by the effort. This is called work input. Next term we are work output. Similar to the work input, now carefully see, this machine is also doing some work on the block or this resistive force. Okay, so here work output we have force into displacement. Force in this case means force applied by the machine on the block is load, and displacement occur on the load side, that is called displacement of load. So load into displacement of load is basically a work output. So what is the definition of work output? Work output we have work done by the machine on the load. This is called work output. Now let's talk about its SI unit. Work input is basically a work, so its SI unit is joule. Next we have work output. Work output is again a kind of work, so its SI unit is also joule. Clear? Next technical term we have efficiency. So what is the meaning of efficiency? So carefully see, here a person is doing some work on the machine and the machine is doing work on the load. So they both are doing some work. Here we are getting work output and here we are doing some work input. So the ratio of work output to the work input, that is called efficiency. So efficiency is what? Efficiency is a ratio of work output to work input. So what is the meaning of work output? Work output means work done on the load by the machine. Work output means work done on the load by the machine. To the work input. Work input means work done on the machine. Okay, so work done on the machine by the effort. So here the formula of efficiency we have, that is work output over work input, and if you will elaborate this formula, then we got efficiency as work done by machine on the load to work done on the machine by the effort. If I'm talking about the SI unit of efficiency, so basically efficiency we are having here work done SI unit joule, work done machine SI unit joules. So joule cancel out, so it is also a pure ratio, no unit. So this is a symbol of efficiency, which is the name of this symbol is eta. Okay, this is pronounced as eta. So this is a symbol of efficiency. Clear? Next we have to see the principle of a machine, or on which principle all these machines are actually work. So the main principle is conservation of energy. What is the definition of conservation of energy? Conservation of energy states that energy can neither be created nor be destroyed. It can be transferred from one point to another point. So here if I'm talking about for an ideal machine, output energy is equals to input energy. What is the meaning of output energy? Output energy means work obtained at a load point. So work is done by the machine on the load. This is called work output. Okay, so the energy at the load point, that is called output energy. So this is basically load into displacement of point of application of load, or simply I can write load into displacement of load. And what is input energy? Input energy is energy given to a machine. So what is the input energy? Input energy is equal to work done at a effort point. At the effort point we are giving a force, or we are giving the energy to a machine. So work done at the effort point, this is called input energy. So this is basically effort into displacement of the point of application of effort, or I can write effort into displacement of effort. Now for the ideal machine, there is no losses. If there is no losses, we will not consider any losses. For ideal machine, efficiency is 100%. But in case of actual scenario, efficiency is not 100% because some losses are there. For an ideal machine, if we are giving 100 joule of energy to a machine, then at the load point whole 100 joule energy is converted, and we are getting 100 joule energy from the machine. But in case of actual machine, this is not possible. For an actual machine, output energy is equals to input energy minus some losses. So what are these losses? One by one we will see. But for example, here you have given 100 joule energy, and 20 joule of energy is actually wasted. Okay, so output energy at the effort point, or sorry, at the load point, we are getting only 80 joule of energy. So this is basically a loss of energy. So what are those losses? One by one we will see. So losses we have weight of a moving part. Actually we are neglecting the moving part in the ideal machine, but in the actual machine, weight of moving part we have to consider. In the ideal machine, we have neglected the friction between the moving part, but in case of actual machine, friction is there between the moving part. Next we have string is not perfectly elastic. In case of ideal machine, string is perfectly elastic, and in case of actual machine, string is not perfectly elastic. What is the meaning of perfectly elastic? Carefully see. For example, we have some string, okay, a rope is there for example. So for example, its length is 50 centimeter. Now under the force, its length gets increased up to, for example, 52 centimeter. Now when you will remove the force, if the rope or a string come back to their same length, same position, that rope is called, that string is called perfectly elastic. Or in some cases, for example, in actual scenario, when you are applying the force and remove the force, there is little bit increase in the length of the rope. For example, it becomes 50 centimeter. Now the string is not perfectly elastic. So due to this not perfectly elastic, it is considered under a loss. Next we have parts are not perfectly rigid. What is the meaning of this? For example, one iron nut is there. When iron nut, we are applying force on the iron nut get deformed. It's changed its shape. So due to the change in the shape and size, then there is also considered it as a loss. So these are the losses. Out of these four losses, friction between moving part is a major loss. Okay. Next we have one question, that is, what does it mean if a machine is 80% efficient? For example, this pulley is 80% efficient. What is the meaning of this? So we know that efficiency is equals to work output over work input. Now if this machine is 80% efficient, it means that 0.8, 80% means 80 by 100. So here we got it as 0.8. So here we got it as work output as 0.8 into work input. It means that if you are giving 100 joule of work to a machine, then you will got only 80 joule of work at a load point. Clear? So where this 20 joule is gone, where you are giving 100 joule, okay, you are getting 80 joule. So where this 20 joule is going, that is going in the pulley in case of losses. Major loss we have frictional loss. So here if a machine is 80% efficient, it means that 80% of the total energy supplied to a machine at the effort point, means 80% of the total energy supplied to a machine at the effort point is obtained at a load point, and remaining 20% of energy supplied is lost in overcoming the force of friction. Means major losses is friction, rest all are there, but those are small losses. Major we have friction force. To overcoming the friction force, 20% energy is lost, and it appears in the form of heat energy. Clear? Next we have to see the relationship between efficiency, mechanical advantage and velocity ratio. So one by one see the formulas. Efficiency we have work output over work input. Okay. Mechanical advantage we have load upon effort, and velocity ratio we have velocity of effort over velocity of load, or displacement of effort over displacement of load. Now we know that efficiency as work output. What is the meaning of work output? Work output means we have load into displacement of load, and here we have work input means effort into displacement of effort. Now here carefully see load upon effort, we got it as load upon effort, just separate this displacement of load over displacement of effort, separate. Load upon effort we have mechanical advantage, okay, and displacement of load over displacement of effort. Actually velocity ratio is displacement of effort over displacement of load, just reciprocal. So displacement of load over displacement of effort, we got it as 1 over velocity ratio. Now put the value as 1 over velocity ratio. So here efficiency we got it as mechanical advantage over velocity ratio. So basically this is the formula of efficiency in terms of mechanical advantage and velocity ratio. So mechanical advantage, efficiency we got it as mechanical advantage over velocity ratio. So multiply here mechanical advantage, we got it as efficiency into velocity ratio. Now here we have some important points, carefully see. For an ideal machine, efficiency is 100%. 100% means 100 by 100, 1. When efficiency is 1, mechanical advantage and velocity ratios are equal. Clear? Next we have when a machine is actual machine. When machine is actual, efficiency is less than 100%. For example, efficiency is 90%. 90% means 0.9. So when you put the value here 0.9, so mechanical advantage is equals to 0.9 into velocity ratio. So mechanical advantage value will decrease. So this is very important point. Carefully see, when the machine is actual means efficiency is less than 100%, then mechanical advantage value is less than velocity ratio. But when the machine is ideal, then efficiency is 100%, mechanical advantage is equals to velocity ratio. And here, if machine is actual, efficiency is less than 100%, velocity ratio will not change, only mechanical advantage will be affected. So with the changing the machine from ideal to actual, velocity ratio will not change, but mechanical advantage will decrease. Clear?